Okay, let's go ahead and get started on the notes here. We're going to do special products factoring today, and what this is really just a way to, like a shortcut. Like if you have some special products, and then we can take a shortcut to factor them based on a pattern that we see. But what I want to do first is look at these two problems without the shortcut. Okay, and then we'll kind of look at the steps for the shortcut and see how it all applies. So going back, remember, it's the first thing you do is make sure your exponents are in descending order. They are. Look for a common factor. There's not here. But then we're going to look for two numbers that multiply times A times C and add to B. Remember, this is ax squared plus bx plus c. So A times C would be 36, and the B would be 12. So what are two numbers that multiply to positive 36 and add to positive 12? Can you give me those numbers in the chat? Or unmute yourself? 6 and 6. Positive 6 and positive 6. So let's split this. Then we'll group them. So I'm going to group the first two and the last two. We're going to pull out common factors. So in the first two, what am I going to get? 2x I can take out. And then on the second one, I can take out a 3. I've got good news going on here because I have common factor there that I can divide out of both of them. So I'm going to have 2x plus 3 times 2x plus 3. And with that, I can write that as 2x plus 3 squared. Okay, any questions there? If you're good, give me a thumbs up, either in the chat or if you've got your videos on. If you can turn your cameras on, that helps, so I can see your thumbs up, or give me a thumbs up in the chat, or use your little emojis. Perfect. Okay. So let's look at the second one. There's no common factors again. So if I do A times C, it's 1,296 and negative 72. Oh my gosh. Those are some big numbers to try to crank out and figure out. Okay, it looks like we have a couple that went through and did it. But before we do that, I want to kind of come down to this factoring perfect square trinomials. So go ahead and copy this down. Give me a done in the chat when you're done copying these steps down. Okay, so a perfect square trinomial is one that fits this special pattern. And we talked about this a little bit when we were, before break, when we were multiplying binomials, when it would come up, what this pattern would look like. But what happens if it's a perfect square trinomial is your first term will be a square, a perfect square. Your last term will be a perfect square. And then this middle term is going to be twice whatever the square of your first term is and whatever the square, not the square, but the square root of your first term. Your first term is before it's squared, and your second term before it's squared. 2 times that. If we have this pattern, then we can jump and write this as a plus b squared. So, and then over here on the other side, you can see this had an addition sign right here. If we have a subtraction sign right there, then the same thing applies. It's just that it would be a minus b squared. Okay. So I want to look at the second problem we did, and let's check and see if it's a perfect square trinomial, and then we can use this shortcut on it. Because otherwise, it's going to take me a while to find those numbers. So, is 16x squared a perfect square? And if it is, what would it be? What would the number be that I would be squaring to get 16x squared? So it would be 4, not just 4, but 4x. Because isn't 4x squared 16x squared? Okay, and then let's look at the last number. Can we write that as a square, as a perfect square? Let me know yes or no and what it is in the chat. Yep, it would be 9. So now this is where we're checking to see if it fits the pattern. Okay. First and last, that's good. Those are easy to recognize. Now this middle term has to be twice 4x times 9. So that would mean it would have to be 9 times 4 is 36, times 2 is 72. Is it 72x? Yes, it is. So since it fits the pattern, now we can, instead of having to go through and find those numbers that multiply times AC and add to B, we can jump straight to writing the solution here. It's subtraction, so it's going to follow this pattern with the subtraction in between. And then this is going to be this 4x. And this is going to be the 9. How about if I have something like this? Check and see if that's a perfect square binomial. And if it is, write it as its perfect square. And if you get the answer, put it in the chat for me. Move on. Okay. So if we're asked to factor something like this, kind of with the tools we have, we've been factoring trinomials, right? If we had something like this, it would be just looking to see if there's a common factor. Well, there's no common factors here, but what I know is that if I rewrite this with a middle term of 0x, because there just isn't an x term in the middle, but make it a 0x. Now what I want you to do is take and factor that. So do a times c and b. What multiplies to a times c adds to b. Use your grouping and factor that for me. When you get a solution, put it in the chat. Okay, and I think I agree with the answers I'm seeing in the chat. So here's the work that went with it. So it was a -6 and a +6 to add to 0. I put my -6 in first and then factored each of the first two terms and the last two terms. And we get 2x plus 3 times 2x minus 3. Now, kind of thinking back to what our pattern was with a perfect square trinomial, this one is something we call the difference of perfect squares. So look at that and see if you can maybe even make up the rule. What if I have the difference of two perfect squares? How do I tell if it's the difference of two perfect squares? And then how am I getting to this? What's the shortcut? I'll let you think about that for a minute. Anybody think they see the pattern there? What the shortcut would be? You can either unmute or type it in the chat. Do it. Okay, so let's look at another one real quick here before you write that down, before I give you time to write this. What if you have is that the difference of two perfect cubes? And if it is, write the solution. Not perfect cubes, perfect squares. If you get the solution, go ahead and type it in the chat. Got one answer there. Anybody agree, or you come up with something different? Just a little different there, right, Seth? Okay. I see a couple. So the first one can be written as 4x squared. The last one can be written as 5y squared. It is the difference. So we are going to say 4x minus 5y times 4x plus 5y. And it doesn't matter which order you put those terms in. Okay, any questions there? So we're checking to see if this is the sum of cubes. So we're checking right now to see if the 125 can be written as a cube. If you figure it out, put it in the chat for me. So what number times itself 3 times would equal 125? I think Alejandro's got it. It would be 5. And these numbers aren't usually going to be very large, so you can kind of just start thinking, okay, well, what's 2 to the third power? What's 3 to the third power? What's 4 to the third power? Kind of on like that. Okay, and then what about 8? Can 8 be written with a power of 3? If it can, put that in the chat for me. Thank you, Daisy. Yes, it's 2 to the third power. 2 times 2 is 4, times 2 is 8. Okay. Make sure you're not counting by 2's, but you're multiplying. So we do have the pattern. They're both cubed. It's addition. Since it's addition, we're going to be using this first pattern. So our A over here is going to be our 5x. This is our A. The 2 is our B. So it's addition. So the first thing I'm going to do is I'm going to do my A term plus my B term. So I'm going to do 5x plus 2. And then I'm going to take my A term and square it. So I'm going to do 5x squared. So it's, let me write it up here, 5x squared, which would actually be written as 25x squared. We want to multiply them out. So 25x squared. And then a subtraction, A times, whoops, sorry about that, I hit my mouse and it threw me out of the meeting. So I'm back. So our middle term is going to be A times B, not twice A times B, just A times B. So 5 times 2 is 10x. And then our last term has addition, and we're going to square this last term. So 2 squared is 4. Then from there, what you need to do is check to see if this could be factored anymore. You're just going to use that as another problem. I'm kind of thinking these are both.
We can't see the notes.
You can't see them? I'm sorry. I guess that's why you're popping in the chat, huh? That happened because I got kicked out. Okay. So since it can't be factored anymore, that is your final solution.